Question number 16 of exercise 4.2. Integration of cos ln of x over x. Let ln of x, this inner function, equals to t. Take the derivative on both sides. Ln of x will give us the derivative 1 over x dx and t will give us the derivative dt. Replace the values that we have taken as a substitution values. Ln of x will be replaced with t and dx over x will be replaced with dt. Cos of t has the integration sine of t, and now put back the substitution. T is equals to ln of x, so we will get sine ln of x plus constant of integration. Question number 17 is integration of 2x plus 5 divided by square root of x square plus 5x plus 7 dx. Move this square root upside. We will get minus 1 by 2. Now check whether we have its derivative in its multiplication or not. If I take the derivative of this inner function, I will get 2x plus 5. You see, you have the derivative present here. So you just add 1 in the power and divide with it. And after simplification, we will get this answer. Question number 18. In question number 18, we have integration of x plus 2 divided by under root 2x square plus 8x plus 5. Again, move this function up and make the power negative. Now take the derivative of this function. We will see that we need 4x plus 8. But this is x plus 2. We can search a number. If we multiply it with that number, we can get 4x plus 8. We will multiply it with 4. It will be 4x plus 8. If I am multiplying 4 with it, I will also divide it with 4 as well. So 1 by 4, and after multiplying 4 here, I will get 4x plus 8. Now this function has present the derivative within itself. So just add 1 in the power and divide it with as well. And just simplify the function, we'll get back this answer plus constant of integration. These are the easier questions. Now question number 19. I told you earlier, whenever you have this kind of function x square minus a square and you have to integrate it, then always let the substitution x is equals to a secant of theta. So now let x equals to a secant of theta. Take the derivative, x will give us dx and a is a constant, secant theta will give us secant theta, tangent of theta, d theta. Replace the values. X square will give us a square secant square of theta and dx will give us this answer. Just replace dx with this answer. x4. Take the fourth power of this function, a4 secant 4 of theta. Simplify this square root. This is simplified in part 1 as well. You can part 1 and 2 as well. You can just refer that part for simplification of this function. We'll get a tangent of theta divided by this a will be cancelled with this 4 and will be left behind a cube here. Secant theta will be cancelled with 1 of the secant cube, will be left behind secant cube of theta. Tangent theta d theta. Now just multiply all these terms and cancel the terms where necessary. We will get tangent square of theta over a square secant cube of theta. Take this constant outside. Tangent square of theta can be written as sine square theta over cos square theta. 1 over secant cube of theta will be cos cube of theta. This will be cancelled with this one. We will be left behind sine square of theta cos theta d theta. Now you see, if I just write it like this, sine theta whole square. This function has the derivative present here. So I can add 1 in the power and divide with it as well. So I will get 1 over a square sine cube of theta over 3. Now I need to find out the value of this sine theta here, because our question was not in sine and cos. It was in a and x dx. What we substitute in the start, x is equals to a secant theta. X over a will be secant theta. If I take the reciprocal on both sides, I will get a over x cos theta. Now from here I can find the value of sine theta, because I know that sine square of theta plus cos square of theta is equals to 1. I need the value of sine theta. So sine square of theta is equals to 1 minus cos square of theta. So sine of theta is equals to under root 1 minus cos square of theta. Just replace the value of cos theta here and simplify it. You will get the value x square minus a square over x. So sine theta will be under root x square minus a square over x. This is the cube. If I take cube on both sides, I will get x square minus a square 3 by 2 over x cube. So writing the cubic answer here, I will get this answer plus constant of integration. Now move on to question number 20. Cos 6x sine cube x. Sine cube x can be written as sine square of x into x. I want to just convert this question in maximum cos function. So just split this sine cube of x to its nearest even power, that is sine square of x into sine of x. Now sine square of x can be replaced by 1 minus cos of x, square of x by using identity. Which identity? This one. Sine square of theta plus cos square theta is equals to 1. Just take the value of sine square of x from there and I will get 1 minus cos square of x. Now these functions are in cos function. Cos has the derivative minus sine. Cos has the derivative minus sine. So I need minus sine here. Just multiply it 2 times so that you can get back the previous step. Keep this one negative sign outside and keep this one negative sign with sine of x. Now just suppose cos of x equals to t. dt will give us minus sine of x dx. Cos 6x will be t6. 1 minus t square, and this function will give us dt. Just simplify this and just integrate it using the power rule simply. Now t was our cos x. So t7 will be cos 7x and t9 will be cos 9x. Question number 21. Integration of, this is the same as the previous question. Tangent cube of x, secant cube of x. I will just convert this question in the maximum of secant form because I know that secant x can be easily solved here. I am just making this tangent cube of x, splitting this in the nearest even power. It will be tangent square of x and one tangent x is written here. Both will combine and get back tangent cube of x. Secant cube of x can be written as secant square of x and secant of x. Now tangent square of x can be written as secant square of x minus 1 because I know that 1 plus tan square of x is equals to secant square of x. So tangent square of x will give us secant square of x minus 1. This will be kept as it is and this term is kept as it is. Now multiply this secant square of x inside. I will get secant 4 of x minus secant square of x and keep this as it is. Now let this secant x as t. dt will give us secant x tan x dx, same as this thing. Replace the functions. Secant 4x will be replaced with t4 minus t square. This whole function is equals to dt, so I have written dt. Simply just integrate this function. t4 will be power plus 1 divided by that. So t5 over 5 minus t cube over t plus c. Replace this t with secant x. I will get secant 5 of x over 5 minus secant cube of x over 3 plus constant of integration. Question number 22. The same question that we did in 20 and 21, the same thing is here in 22 but with different functions. 22 says we have to integrate cot cube of x plus cosecant 4 of x dx. Cot cube of x is splitted in cot square of x. I have taken its one function aside, cot of x. Cosecant 4 of x is written as cosecant cube of x. I have taken also its one of function cosecant x aside. Now I have multiplied minus with minus sign because I need minus sign here. If you don't multiply it here, then you can also take it after taking the substitution. The answer will be the same. Cot square of x can be written as cosecant square of x minus 1 because we know that 1 plus cot square of x is equals to cosecant square of x. So in place of cot square of x, I have replaced it with cosecant square of x minus 1. The rest of the things as it is. Multiply this cosecant cube of x inside. We will get cosecant 5 of x minus cosecant cube of x and this function as it is. Now let this cosecant x as t. Just differentiate it. Cosecant x will give the derivative minus cosecant x cot x dx. Due to this negative sign, I multiplied it in the start. dt. So we'll just put this cosecant x as t. I'll get t5 of x, t5 minus t cube, and this function is dt. Now integrate this t5, this will be t6 over 6. Negative with negative sign will become positive. Integrate this t cube, we will get t4 over 4 plus constant of integration. Just replace t with cosecant, we will get minus cosecant 6 of x over 6 plus cosecant 4 of x over 4. I hope you understand till question number 22. From question number 23, we'll start in the next part.